Now, please welcome Laura, as she will be giving the next keynote on building secure software. Yes.
All right. Bonjour, ça va? Donc, je vais continuer en anglais parce que je n'ai pas la confiance en français. Mais si vous avez des questions, trouvez-moi dans l'expo. Thank you for your time today. Hi. Right. Okay. This is an awesome time to do a keynote because I've just had somebody tell you about the wondrous future that we're about to have. And I'm a security person. And what do we do when there's a wondrous future? Any suggestions? Well, this is me. I'm a bit unusual for a security person in that I'm a security optimist in a way. Yes, the world is a terrifying nightmare. But also, we're building the amazing technology that we literally read and dreamt about when we were kids. How many of you will raise your hand and admit you're a sci-fi nerd in some description and have read a book from the last 50 years that describes a technology you now can use today? Yeah? How exciting is that? And we, as engineers, we're not just using it, we can go build it. We can go create the crazy AI nightmare that's going to tell people that they can't do that, Dave. So, I really love the future. I am a particular fan of robots. Now, I love that Elon's doing robots. It's cute. But I've been watching Boston Dynamics for a very, very long time. And before Elon became what Elon is now, then we had Spot. Now, what I love about this is the potential. This is terrifying. Like, do not get me wrong. This is the type of stuff that gets built by the DoD, the Department of Defense. But also, it's called Spot. And therefore, like, part of me regresses to this childhood stage of going, I can have an AI dog that won't poop. So, I have had a weird career. And it's going to link into this talk today. In this talk today, I'm going to take you through 3 of the projects that I've built over the last 15 to 20 years that have been revolutionized by the way we've changed technology. Then I'm going to show you what this means for security, because spoilers, the way we do security now isn't going to keep up with what we need to do to build these amazing things. And that's going to take a bit of help from you to fix. So, let's talk about my horrible history of code. Now, raise your hand if you wrote code at some point you wish had never existed. Great, thank you. I'm among friends. Okay, so let's go to 2005. So, age 23, I went to work for CERN, which is the particle physics research laboratory in Geneva, which is wonderful. And they asked me, age 23, if I would write real-time radiation monitoring software. Great, awesome. So I had a solo project where my job was to write little bits of code that would monitor for leaking radiation from the particle accelerator, so when the beam goes to the wrong place, and then safely send that somewhere, which in this case is a giant bunker under the ground made of concrete. So everyone feeling safe with the idea of a 23-year-old fresh out of university was writing this software. Great, fantastic. I wasn't comfortable. If you have a past like mine, there's many bits you just kind of look at and go, just don't ask me. And if Switzerland disappears, it's not my fault. So at the time, it was custom hardware, as most things were. And these little boxes all the way around the big circle that was the beam. And to do this, on my first day, my very enthusiastic manager, he said to me, I've been reading a paper in New Scientist, and Java can do real-time now. And I was like, what? And so we spent 3 months trying to write real-time Java. Spoilers, it never happened. Like, you can read all the papers you like, it never happened. In the end, we wrote it in C++. That conversation led to like a whole 2 years of work, a massive amount of software that was very safety critical. Now, how has this changed today? Well, I love, one of my favorite things about technology is for anything that you think is hard to build, you go and look on AliExpress and see if it's actually a thing. So now, we can buy an Internet of Things device for $112 that will monitor radiation for you and alert you in real time. Fantastic. What do we think the code quality is like? Oh, it's exciting and slightly horrifying. Okay, we'll come back to it, don't worry. So next project, natural language processing. Now, I was silly enough to do a degree, my undergraduate, in artificial intelligence and robotics. Before that was a viable career path. So again, not good at planning careers. So at the time, I decided for my thesis, I was going to write a piece of chat software that could talk to me in French, and I could practice my French back and forth. Now, what I'm trying to say, but sound nerdy, is I had no friends. And so I built myself a French friend. And I did that in Java, again. Like, I've reformed, just for the record, I now do Python. But, yeah, I was going to identify parts of speech, it had a conversation with me, and then it would grade my responses and tell me what I'd done wrong so I could improve. And it worked. It was cool. It was 30,000 lines of Java. And it was all based around statistical natural language processing. So that hyperdimensional graph that Gerard showed us, this is how you make these by hand. And it takes a long time. But it was fun, and it was cool, and it was 20 years ago. And so I decided very recently I'd try and rebuild it. Why not? And this was before ChatGPT went open for us all. So I went into Python. I was like, well, how do I do this? Well, it turns out my 30,000 lines of Java are now 8 lines of Python. Oh, great. So this bit here, for example, this was me getting fancy. I decided I only wanted structures that had certain phrasing, so adverbs, pronouns, and determiners, and I wanted to, do the same sort of parsing I was doing when I was correcting someone's French. And again, I was slightly underwhelmed. Because, I actually kind of like problem solving. Engineering types in the room, raise your hand if you actually enjoy the problem solving part of software. Yeah, it can be a little bit frustrating when you realize that actually 7 lines of Python and you're done. You're like, oh, okay, all right, suppose I'll go and watch Last of Us or be done with it. So now, I wrote these slides literally 2 months ago, and it's out of date. Back then, there was an AI that we could sign up for that would do it for free, no code, fantastic. And now you can just go on Google and slam your code into it and job done. Fantastic. Now, for the record, and I'll come back to it, raise your hand who thinks it's a good idea to put your source code into ChatGPT. Great, awesome. I don't need to teach you that this is a terrible idea. Just because they decided that they could help themselves to GitHub, it doesn't mean you need to give them extra that they didn't know about. Right, finally, my third project I want to go over quickly before I get to what we can do about security as a result of this and what we're learning from it, what you can do next, is I decided after all of this, I'd done radiation monitoring software, I'd done natural language processing, I'd go and handle terrorism because, why not? So in 2007, I was employed to try and stop and limit online harm to minors on the internet, so protect children online, and to do counterterrorism. My particular job was to map the relationships between individuals on a forum. So for those who are much younger than me, a forum was like social media, but with less idiots and way less animated GIFs. Now, my job was not to look at their names and their IPs, it was to look at the parts of their language. So could I create a profile, a heuristic, of a person based on their interactions and identify the same person on multiple accounts so I could spot who was pretending to be who. Now, this is a V-Bulletin forum. For those of you who are old enough to remember, this was what the cool kids did back in the early 2000s. And back then, the solution to doing this sort of problem was Perl. Now, Perl is never the solution anymore. Don't do that. Friends don't let friends do Perl anymore. But we had to write custom scrapers that would take massive data sets, which was essentially a database dump, and then turn that into the structure and then the language, and then deobfuscate the language using a lot of regular expressions. The type of code that, you had to be drunk to read. Now, for those of you going, yeah, but I could do this way easier, please remember your timeline. V-Bulletin was around in 2000. Facebook didn't launch until 2004, and all those nice technologies you would now use to solve that problem were not even conceived yet. So D3, mapping relationships and doing a nice little bouncy JavaScript graph, not a thing. Now, how do we do this today? Well, I want to show you an example, something you can go and play with. So this little bit is a representation of a similar problem they're doing with the Conti ransomware group. So Conti was ransomware that would lock up your computer and wants you to pay money to get it free. Now, Conti is a huge organized crime organization suggested to be out of Russia. Now, it was so severe, the impact of the Conti ransomware group, that the US government put up the first ever bounty or reward for information on tracking that group. And now you can do some great research, there's lots documented on it. But as a result of doing the research into Conti, Microsoft open sourced some really cool tools, including Mystic. Now, Mystic is a Python framework that allows you to map the relationships between entities. Now, what does that mean? It means that you can say, hey, this is connected to this via this attribute. So we think this happened at the same time or in the same place or was the same language. And that means you can take a large unstructured data set, like I did in the olden days with the vBulletin forum, and you can turn it into something wonderful. Now, this pretty diagram here is an actual render of the relationships, the human relationships in the Conti ransomware group. And as a result, when you start scrolling through this ecosystem, you can start to see the power players. You can start to see what's going on. And so rather than it being a large, complex thing, there's now tools you can use that just solve this for you. And that's a wonderful thing. I think this is great. So security isn't going to work in this space. Let me show you why. Our security guidelines were built for code that was, not code that will be. This is the OWASP Top 10 from 2003 versus our latest edition. There is no prizes for spotting the fact that they are largely identical. Now, if in 15 to 20 years nothing has changed on OWASP Top 10, raise your hand if you think we're winning at security. Not so much. Now, I don't think the OWASP Top 10 is the solution. I think OWASP is a great group and this is a great resource, but the future of this isn't this. It's something else. Because to protect us from what will come in advance, we need to be thinking about that. We can't protect ourselves from the future by looking behind us. So these are the security challenges we're going to be facing with building the amazing things of the future. Our architectural complexity is the highest it's ever been. And we're talking and looking at the big bulbous orb that is going to be GPT-4, and we're commenting that the people don't understand what's happening inside that. That's true. Now, I teach threat assessment, the idea that you can look at a system, map the pathways through it, and say what the bad pathways are, when it could go wrong. If you don't understand how something is going to work because it's dynamically changing, you can't map the pathways. You can't say in advance what the bad situations could be because it's dynamic. And that's terrifying, but also an exciting problem for all of you to start thinking about. We're using more third-party integrations. Just to repeat myself, do not put your code into ChatGPT. But we're sending our stuff all over the place. Our systems aren't built all from scratch anymore. They're not 30,000 lines of terrible Java. They're 10,000 lines of terrible Java and 16 APIs. We have a larger development community. When I started doing this, these rooms were much smaller. And now look at all of you, and this is a fraction of us. There are 30 million software developers in the world right now, growing at a rate of 1.6 million a year. That's fantastic. But it also makes it really hard for us to all work together, because there's a lot of us. We have continuous availability, non-linear pathways, and increased regulation. It's going to be hard. So some of the security challenges you're going to be facing are on this slide here. So for each project, these are the types of things we're going to need to consider. How long is our code supposed to be safe for? Is it for the whole life it's used, or just for 2 years because that's the commercial period? How are we supposed to deal with a non-linear pathway through code? How do we deal when our understanding of the system we're connecting to is limited and our control over it is almost none? These are huge problems, but don't be put off by them. I'm not here to tell you your baby in the future is ugly. All software is ugly. We all write buggy, horrible code every day. That's okay, we accept this. But, oh, thank you. My mom's proud too. But don't overlook some of the challenges we have to solve. And we're engineers. What we do best in the world is solve problems. So don't ignore these ones just because they're security. Make them part of what you're doing every day. So there's 30 million of us, myself included. And if each one of us did even just a little bit of this with the future systems we're building, then that's quite powerful. Right now, less than 5% of organizations out there actually do any security. I've been surveying these now for my entire career, and I can say, hands down, we're not doing it. Raise your hand. I'm going to do it, actually. Let's do the big room version. Raise your hand if you actively have done any security training on secure development in your career. There's 800 people in this room, and less than half of you raised a hand. How many of you can actually remember what you learned on that course? Thank you. How many of you know that security is something you're supposed to do, but it's kind of at the end and somebody else is going to do it? All right, there we go. And my final favorite question, how many of you have never been hacked, so it's not a problem? Good on you. All right, so if we all admit we're here and we're engineers, then we have a problem to solve and we have the skills to fix it. I don't want the security future to belong to people like me. I want it to belong to all of us. Because all of our dots that we think are separate systems are not. All of our architectures, our ecosystems, our libraries are connected to each other. We call this transitive risk. Every time you connect to another library, another framework, yes, it can hit your performance. There was a great talk about that yesterday. But also, it inherits other people's code. And if you raise your hand and say, I write buggy code, well, they write buggy code too. Only you can't change this one. So this transitive risk gives us NPM, but it also gives us .NET and Java and all those languages. Every single ecosystem has connection. And so when you inherit that code, when you call somebody else's API, we all become part of the same challenge, the same system and the same problem. In the press, they'll call this a supply chain attack. But actually what we mean is an attacker is lazy and opportunistic. They will attack whatever the easiest thing is to attack. It's not about you. They don't know who you are. What they see is a target, something that has value to them, and they want to get it. So they'll attack any part of a system to get to it, not necessarily the bit you've put all of your time and effort into. So to protect one of us and one system, we have to protect all of us. If one of us is breached, we're all going to be breached. So how do we make amends for this? Well, here's some things for you. This is the slide for those who want homework to take back to your boss and say, what did I learn we should do at a conference? That slide. So I want you to do these things. I want you to understand your systems. I want you to be honest with the systems and how much code you actually wrote to how much code you inherited. When you start playing with AI and machine learning, I want you to really consider how you understand what your crazy new software machine does if you don't understand the pathways through it. And I want you to play. I want you to think about all of the bad things that could happen. Don't do it. Don't do the bad things. Just think about them, because that gives you problems to solve. And that ticks off that little bit in your brain that solves problems. So you don't have to be bored because 9 lines of Python is going to do your job now, or ChatGPT is going to do your job. Don't worry about that, because there's this whole heap of new challenges coming through as a result that we need you to fix. The future of secure development doesn't belong to people like me. My job in the world is to become redundant. It's to get you lot realizing that this is something you are uniquely equipped to solve. Now, my little contribution to this, and I promise you, absolutely hand on heart, as the CEO of a company, is not a sales pitch. I am going to give you free training. That is free. Completely free, no credit cards, no strings. You can find me in New Zealand and hunt me down if I tell a lie. If all 800 of you did some security training and did even just 1 hour of security every sprint, every 2 weeks, think about how much security we would do as a room in a year. And if we're going to have this amazing future of robot dogs and doctors that can solve cancer and all of these wonderful things, then we're going to need you to do it. So that's me. Thank you so much for your time. Come find me with questions if you have them, and enjoy the rest of your day.